Hello everyone, welcome to GATEFORUM. So let's start this video lecture. So in this YouTube channel, I welcome you all to this session. Strain and its type. So basically, we are going for normal strain basically. Basically normal and shear strain basically we are going for. So here I am writing normal and shear strain. Here we are going to normal strain epsilon. So what is normal strain? Basically change in dimension to original dimension. Basically we are saying change in dimension to original dimension, change in dimension to change in dimension to original dimension. Suppose we are saying that longitudinal strain. We are saying as longitudinal strain, longitudinal strain longitudinal strain. If you are going for that is change in length to original length. Mostly we are using this as a strain, change in length to original length, and unitless, no unit, change in length to original length. Okay, then we go for lateral. Suppose let's say lateral, if you're talking about lateral strain, so it can be suppose uh, change in dia to original dia, change in dia to original dia, that also unitless. Then volumetric strain, if you go for volumetric strain, so volumetric strain, that change in volume to original volume, change in volume to original volume, this is volumetric strain. So here we have normal strain basically. So mostly we are going for this one, that is change in length. Suppose here we have a rod, and after application of load, the length of rod increases by some particular amount delta L. Let's say this is delta L. This is change in the length, increase in length, and this is the actual length of the rod, original length of the rod. So what about strain? Strain is nothing but change in length to original length. Change in length to original length is known as basically strain, which is longitudinal strain here. Mostly used this one. We can go for change in diameter to original diameter in the lateral cases. We will discuss this one also. Okay. Now if you go for the shear strain, that what is basically shear strain? Just look at here. If you go for the shear strain, very simply, if you go for shear strain, so shear strain will be like this. Shear strain gamma. Suppose here we have a body. Suppose here we have a block which is fixed on the lower side, and one force is applied here. Tangential force is applied here. What happens? This body will tilt a little bit. This body will tilt a little bit like this only by some angle phi. By some angle phi, this body will tilt here like this only. So what happened? What is shear strain? So shear strain, you can say from here to here, how much shifted here? So this point shifted delta L here like this only. And the distance between here to here is L here like this only. So in this triangle, shear strain gamma will be shift delta L by L here like this only. Shear strain delta L by L. And what about delta L by L? So basically it is nothing but tan phi. Basically perpendicular to base, which is equal to tan phi. And since very small angle, so which is nearly equal to only phi. So shear strain will be either delta L by L, or it is almost equal to phi, which is almost equal to phi. That is the angle through which body tilt. The angle through which body tilts here. Also unitless here. This whenever we have strain, always unitless. Always here we have unitless. No unit for the strain. No unit for the strain. So here we have a shear strain, as well as here we have a normal strain. Longitudinal change in length to original length, lateral change in diameter to original diameter, and volumetric change in volume to original volume. Okay, and for every type of strain, unitless. Do not put any type of unit. I'm telling you here. Okay. Okay. Now Hooke's law, elongation or different bar. If you go for Hooke's law, very interesting and very important, because from here so many numerical will be coming from this portion. Should I write this? Yeah, definitely I should write. From this elongation topic, mostly numericals will be from here only. Mostly numericals will be from here only. Mostly numericals will be from here only. Okay. So what I can say, mostly numerical will be from here only. Okay. So I will say that we should go for elongation in the best possible way. Okay. Now what is Hooke's law? Basically, if you go for the Hooke's law, it's very simple. Hooke's law means stress directly proportional to strain, or stress is equals to, if equal, there is some proportional sign here, equal to sign, some constant E into strain. And what about this E? What about this E? E is known as Young's modulus. E is known as modulus of elasticity, or it is known as Young's modulus. This is Young's modulus basically, or E is equal to normal stress to normal strain. Normal stress, and what is the unit of E? Same, Newton per meter square or Pascal, because it is on only stress, because denominator is epsilon, which is shear strain, unitless. That's why only numerator unit will be here only. Newton per meter square or Pascal only. Here we have E. And this E is property of material. Young's modulus is basically property of material. What is the meaning of property of material? Property of material means it is a fixed value for given material. Means it's a fixed value. It's a fixed value for a given material. For example, suppose for steel, the value of E is always constant, which is equal to 200 gigapascal. 200 gigapascal. And what is the meaning of gigapascal? Into 10 raised to 9 Pascal. Suppose somebody is saying kilopascal. Kilopascal is nothing but 10 raised to 3 Pascal. Somebody is saying megapascal. Megapascal is nothing but 10 raised to 6. 10 raised to 6 Pascal. Somebody is saying gigapascal. Gigapascal is nothing, 10 raised to 9 Pascal. Okay. Somebody is saying, suppose millipascal. Suppose somebody is saying milli. So 10 raised to minus 3. Somebody is saying micro. Micro means 10 raised to minus 6, like this only. Somebody is saying centi, just like centimeter. Centimeter means 10 raised to minus 2, like this only. Centi, milli, micro, like this only. Please remember this conversion. Okay, do not forget. Centimeter, millimeter, micrometer, like this only. Kilopascal, megapascal, gigapascal, like this only. Okay, these are the conversion. These are the conversion. So here we have for steel, the value of Young's modulus is a constant value. Is a constant value. It is not changing for the steel. It is not changing. But if material changes, suppose you're saying I'm not going for steel, I'm going for the aluminium, then the value of E will change, not 200. Suppose we are going for brass, we are going for bronze, going for copper, the value of E will change for different material. But once material will be finalized, suppose E steel and its Young's modulus 200, so always it will be 200. It will not change. It will not change. Always Young's modulus is a property of material which is a fixed value for a given material. That is same. And please remember for steels, in gate examination, so many times it will happen that the value of Young's modulus steel will not be given. So by default, you have to consider 200 gigapascal, which is 200 into 10 raised to 9 Pascal. Okay. So here we have Hooke's law, and now we'll go for the elongation. Now we'll go for the elongation. What is basically elongation? That is change in length, or the increase or decrease in the length, we can say, for the elongation. Okay. Suppose here we have a rod. Suppose here we have a rod, and suppose you apply force on the rod. Suppose you apply force on the rod like this F. Suppose you apply force on the rod. Now what happened? Suppose the length of the rod increases like this. Suppose the length of rod increases from here to here. Length of rod increases from here to here. Let's say this is delta L. So this delta L will be known as elongation. This delta L will be known as elongation. Here we have. Okay. And suppose in compression also, whatever the reduction in the length is also, we can say as elongation also. Means formula will be same for both. That is change in length. That is change in length here we have. Now, since we know from the Hooke's law on the last page, the stress is equals to Young's modulus into strain. What is stress? Force upon area, or you can say P by A, because for force you are saying P na, for force you are saying P here. So P by A here we have P by A. Stress is nothing but F by A or P by A, force load upon area. Here we have Young's modulus, and what is strain? Change in length to original length. So from here, what is the delta L? So P into L divided by A into E is the value of delta L here, like this. This is the final formula for elongation. This is the final formula for PL by A. PL by A. This is the final formula. Very important formula, PL by A. Delta L equal to P. How much increase in length or decrease in length? Valid for both increase and decrease in length. Delta N can be positive also, and then delta L can be negative also. Formula valid for both tension as well as compression. Tension as well as compression only. Okay, but formula will remain same. Delta L remain formula. Change in length formula will remain same for tension compression. PL by A into E. This is the formula. But there should be one condition also. So many students used to use this formula blindly, but don't use this formula blindly. Otherwise you will do mistake, right? Not blindly. Why not blindly? Why we should not use this formula blindly? Because since we know na what is change in length formula delta L, you will say, sir, right, you told PL divided by A into E. PL divided by right now you have told. Okay, yes, definitely. But when this formula is valid, when the value of load, when the value of area, and when the value of young modulus, all three must be constant. All three must be constant only. Then only I can use this formula. Then only. When this formula is valid, when all three load, area, cross section area, and Young's modulus, all these three things must be constant. I'm not saying should, must be constant. Okay. Suppose if any one will change, let's say let's say P is not constant. Let's say P is not constant. Let's say P is not constant. P is not constant, but area and Young's modulus, these two are constant. These two are constant, but load is not constant. What happens? Suppose here we have a rod. Suppose here we have a rod and force is applied here like this. On this rod, force is applied here, but this force is a function of x depending on the length. Depending on the length, here we have suppose x. Suppose here we have x depending on the length, and if force is a function of x, it will depend on the length. Suppose if somebody is saying F equal to 100x square plus 500x, 500x like this only. So force is a function of x, it depends on x. So what I can say, I should go for integration. I should go for very small section dx. I should go for a small section dx. And what is the value of delta in this situation? Same thing. PL by A. But instead of P, that is force. Instead of force, here we have function of x. So P into L divided by A into E. But L will be replaced by dx. L will be replaced by dx. PL by A. But instead of P, we will write function of x. We will write here function of x. That function of x. PL divided by A into E, like this only, and 0 to L, integration from 0 to L. L is the length of rod. L is the length of rod, 0 to L. In this way, we will get the value of change in length, delta L or elongation for this type of bar where load is not constant. Understood? So whenever load is not constant, you should go in this way. Okay, very simple. Very simple. Elongation under multi-axial loading. What happened for elongation under multi-axial loading? Whenever suppose we have this type of condition that we have two or more than two types of load. We have two or more than two types of load. Just look at here. Suppose this will be the condition. That here we have a metal bar, and suppose load is applied here in this. Load is applied here also like this only. Okay, and load is applied here like this only. Let's say here we have 100 Newton. Let's say here we have 50 Newton. Okay, and let's say here we have 200 Newton. Let's say here we have 200 Newton like this only. So multi-axial loading here we have. So for the different portion, I should get the value of. For the different portion, I should get the value of. Suppose here we have first portion, here we have second portion, and here we have third portion. For the different portion, I should calculate the individual value. Like this only for the different portion. What is the value of forces in the individual? That is in the third, in the second, in the first. Let's say suppose here we are saying 100. So here we will balance it with the 100. So here we have 100 and here we have 100 like this only. Now here this side we have a 50 here. This side here we have 50 na. So we will go for 150. Go for 150 here. So here we have 50. Just a second. 50 direction is different here. 50 direction is different. Just a minute. 50 here we have. Let's say here we have 50 here. So on here we have 50. So what I can say, 50 will be this side. Yes or no? Yes or no? No. This side. Why this side? This side will be 50. Because this 100, the 100 minus 50 will become 50 this side only. And here to balance this will be here 50 only. And here we have 200. This side here 200. So here we will write 150. Why 150? In the same direction 150 plus 50 it will become 200. It will become 200. So this side become 150. This side become 150 here. So this one is positive tensile. This one is negative, and this one is also negative here. negative. So what is P1? Somebody will say, what is P1? What is the P1 in first portion? So 150. Here we have one. What is P2? Load in the second portion. So load in the second portion is 50. Load in the third portion. Load in the third portion is 100, let's say. And somebody will say, what is stress in the first portion? So whatever load in the first portion divided by area, stress in the second portion, whatever load in the second portion divided by area, and stress in the third portion, whatever load in the third portion divided by the area, like this only. And what about delta L total? What about delta L total? So delta L total you can write in this way, that first one is the positive, that is a tensile, positive delta L1. Second one negative, so minus delta L2. Third one is also negative, minus delta L3, like this only. And what is the formula of delta L? And what is the formula of delta L? PL by A. So here we have P1 L1 divided by AE, like this only. Then minus P2 L2 divided by A into A, minus P3 L3 divided by A into E, like this only. So here in this way we can get the value of total change in length, delta L total, like this only. So this is very simple, multi-axial loading. So many questions, so many PYQ. Should I write so many PYQ from here? So many PYQ, previous year gate questions from this topic. Previous year gate question topics, so many from multi-axial loading. So always get the value of load for the different individual portions and then write delta L total, you will get your answer. You will get your answer very simply. Here also multi-axial loading. Series and parallel bar, very simple. In series in series and parallel, what I can say, just look at here. In series, what happened basically, if you go for the series here and you go for the parallel here, let me tell you once again one thing, that I am telling you this subject to so that you can prepare for your next gate examination. Prepare for your next gate examination. But this is not a whole course. This is not a full course. Okay, for gate examination for this subject strength of material. I am helping you with this video on the YouTube of Gate Forum channel so that you can get an idea. You can get an idea, but not only idea. I'm not providing only just idea, but I'm telling so many things in very short duration. But even though this is not a full course, you might be thinking, sir, you are covering all the topics here. You are covering all the topics here. Yes, almost I'm covering all the topics. Okay, here almost I'm covering all the topics here. Okay, almost I'm covering all the topics here. But what is the difference? Here I'm telling you the most important things only under the topic. But in the full course, I will be discussing in detail all the things as well as so many numericals. So many numericals you will practice in the classroom. Okay, in the online classroom. Okay, okay. So definitely. So please remember. Otherwise, do not think that this is the only things we will be doing for the gate examination. No, this is just for help only on the YouTube channel so that you can come to know about the topics, what are the topics, what are the things under the topic, how you should go for, like this only. But this is not full course. Okay, okay. Now series and parallel combination. Okay, series and parallel combination. So what happened in series combination? Just look at here. In series combination, what I can say, suppose here we have rod. Here we have rod, suppose let's say, and it is of 2 or 3 different sections, 1, 2, 3, like this only. Here we have length L1, here we have length L2, here we have length L3. And here suppose let's say area may be different, may not be different. May be different, may not be different, like this only. And here load is applied here, let's say P here. So in series, what happened? Same load first of all. Same load first of all in series, that in the first portion P1 is equal to P2 is equal to P3 is equal to P. In series same there first of all, and second thing, delta L total will be added. Delta L total will be added here. Delta L total will be delta L1 plus delta L2 plus delta L3 plus delta L3. But what happened in parallel? Just look at the first portion, second portion, third portion. Here we have first, second as well as third portion. Okay, but here in parallel what happens? Suppose here we have one rod. If here we have one rod, and suppose here we have another rod, here we have second rod here, and there is one rigid bar which is hanging with the help of this rod. These rods here, length is let's say L1, length is let's say L2, area is let's say A1 here, area is let's say A2 here, Young's modulus is let's say E2 here, Young's modulus let's say E1 here, like this only. Okay, and force is applied here P. Force is applied here P. So here in case of parallel, force P will be equal to, first of all, P1 plus P2. This is our equation number 1. This is our first equation. This is our first equation. And second thing, if suppose P1 is the value of load here and P2 is the value of load here in this bar, after pulling, the elongation or extension in both the rods will be same. That is delta L1 is equal to delta L2. Just opposite na, just opposite of series. In series what happened? Load is same and delta added here. But in parallel, load added here and delta will be same way like this only. So here I can write in this way that P1 L1 divided by A1 E1 like this only, and this will be equal to P2 L2 divided by A2 into 2 like this only. Here we have equation number 2. If you solve equation number 1 and 2, I will get the value of P1 and P2. I will get the value of P1 also and I will get the value of P2 also after solving 1 and 2. After solving 1 and 2, I will get the value of P1, P2. That's it. Solved. If somebody will ask what is the stress in the first, definitely I can get. Stress in second, definitely I will get. So here we have series and parallel combination of bar. Very simple. Okay. Now, statically determinate and indeterminate bars here we have. So statically determinate and indeterminate. So basically, statically determinate, that is in multi-axis loading I have discussed with you, and statically indeterminate bars we will go for pro level in the paid courses. So we are not discussing this topic here, and statically determinate bar we have just done here like this. We have just done all this bar. All this bar is statically determinate here. We have all this bar here. Whatever we have discussed, statically determinate bar here. Okay. Now we will move ahead. Here, induced stress, permissible stress, and design on strength criteria. Try to understand this topic in the best possible way. Try to understand in the best possible way that what is induced stress, okay? What is induced stress, what is permissible stress, as well as what is design on the strength criteria. Okay, very simple. Very simple. Just look at here. Suppose if you go for the stress, how many types of stress? So basically, just write two types of stress. The first one is induced stress. And the second one is a permissible stress. Second one is the permissible stress. Okay, so what the difference of these two? Just take one example. Suppose if here we have one person, and suppose here we have one person, and suppose we don't know how much this person can sustain load on his head. Worker, suppose in any factory or company, suppose any worker in any factory, and I am supervisor there, I am new worker, I am not knowing about the new worker, how much load he can keep on his head and he can move on the ground. How much coolie or worker like this only. Suppose I am writing coolie. Suppose I am writing cooling or worker in the plant or in the company, and how much load in terms of kg, he can put on his head and he can go. So if I am not knowing, I don't know this now. So what happens? Suppose if I put very small amount load to him, so it will be lost to the company. And suppose if I put very large load on his head, maybe he will die. He can die. Maybe he can die or fail. Only. So what I will do, I will go for a lab test. And the same thing happen with the metals also. I'm telling with the help of one human being, the same thing happen with the metals also. Okay. In the lab test, what I will do, I will put 1 kg weight on his head. First I will put 1 kg. Second, then I will put again 1 kg. Then I will put again 1 kg. Then again 1 kg like this only. And suppose after 20 kg, he is not able to, he will say that I will not able to sustain right now. Please hold me like this only. That means I will come to know the maximum load bearing capacity for this human being or this worker is only 20 kg, and that 20 kg is known as permissible value of the load only. For that human being, I will write 20 kg in my brain. Suppose the name is suppose the name is Mohan. Suppose the name of this person is Mohan. So I will note down in my brain that never put more than 20 kg load on Mohan, otherwise Mohan will die. Always put load either 20 or less than 20, not more than 20. Not more than 20. Understood? Very simple. This is permissible stress. After lab test, same happen with the metal also. Permissible stress is the maximum load stress. Maximum stress it can bear. Maximum stress it can sustain. Maximum stress material can sustain. Material or rod can sustain, and this is known with the help of a lab test. With the help of a lab test, this is known here like this only. Okay, for example, for some metal it's, let's say, 200 megapascal. Yeah, 200 megapascal. Yes, after lab test, for any particular metal we come to know. Okay, and this is property of material. Again, this is property of material is a constant value, fixed value for a material. Again, this is property of material, fixed value. Property of material, that means a fixed value. Fixed value, never changing. Okay, suppose, let's say, permissible stress, sigma permissible, let's say sigma permissible for any material is 150 megapascal. 150 megapascal, so it will be constant 150 megapascal for that material. That means that material can sustain maximum 150 megapascal, not more than that. But what about induced stress? Induced stress is not lab test. It is just stress according to load. It is stress according to loading right now. According to load right now. According to load right now. So whatever the value of load divided by stress. So induced stress I am writing, induced is nothing but whatever the value of load applied divided by area. This is known as induced stress. Simple. If load increases, if the value of load increases, stress also increases. If the value of load increases, induced stress also increases according to load only. According to the load only. Load increases, induced stress. So induced stress is not a constant value. Induced stress is not a constant value. Why this is not a constant value? Because if load changes, stress changes. But permissible is a constant value. Permissible is fixed value. After the lab test of the material, we come to know it is 150 megapascal. It's a constant value. Not more than that, not less than that. But induced stress will be a constant, will not be a constant value. Now, when material will fail or when material will be safe? Suppose if you are saying that when material will be safe or one metal can fail. Suppose if you are going for this rod. Suppose if you are going for this rod and some load is applied on this rod. Load is applied on this like this only. And suppose we are talking about the safe condition. Talking about the safe condition as well as failure condition. As well as failure condition or fail condition here. So whenever, right now told you that human being lab test, after the testing in the lab of that human being, we come to know 20 kg is the maximum value of load. 20 kg is the maximum value of load. So what happen if we put more than 20 kg on him? He will die or fail. So if the induced stress will be more than the permissible stress, so definitely material will fail. Definitely. But if the induced stress is either less than or equal to the permissible stress, then I can say this is the safe condition. This is the safe condition. Very simple. Okay, so many questions in PYQ, previous year gate PYQ, in previous year question paper of last 32 years PYQ. So many questions from this topic: permissible stress, induced stress, permissible. For safe condition, always remember this is the safe condition and this is the failure condition. Induced stress as well as permissible stress. And here we have one term, factor of safety also. Factor of safety and working stress also. But we are writing this much only here. Rest will be done in the pro level, that is in the paid course here. But here we have one idea, and with the help of this concept, definitely you can solve any question of the GATE examination. So here we have induced stress, permissible stress. With the help of very simple example, I have make you understand that what is induced stress, what is permissible stress basically. Okay, very simple, I think. Very simple, I think. Not so difficult. Not so difficult, I think. Okay. 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 So here we have this induced stress as well as permissible stress here. Very important topic. So many times question from permissible stress in our syllabus. In our syllabus in strength of matter. Very important. Please try to understand that what is induced stress, what is permissible stress. Okay. And what is here, what is safe as well as what is the meaning of failure. What is the meaning of failure? Now, what is isotropic and homogeneous material? What is isotropic? Just look at here. If somebody is asking you what is isotropic material, isotropic material means if you go for the isotropic now, isotropic materials means and homogeneous isotropic material means the value of elastic constant, the value of E same in all three directions, same in all three directions. And homogeneous means the value of elastic constant same at all points inside the body, at all points. For example, here this side, let's say here the value of E will be same in all the three directions. Here also E, here also E, here also E. But what about homogeneous? The value of E will be same at all the point. Here E, here E, here E, everywhere E. E like this here, E like this here, E like this. So isotropic, homogeneous, and we have isotropic and homogeneous means at all points in all direction. E same at all points in all direction. So the value of E, it means the value of E. It means the value of E same, value of E same at all points and in all direction. For example, suppose here we have a material, here at this point, here we have E, here we have E. Okay. So the value of E will be same. Same at all points in the all direction. This is isotropic and homogeneous material. Here we have. Okay. So in this class we have done so many things. Okay, we have done so many things in this class. Basic stress and strain. Basic stress and strain. We have done so many things. We have done so many things here in this first class. So this is our lecture number 1 on this YouTube channel, on this Gate Forum YouTube channel. Here we have, today we have done our lecture number 1. Today we have done our lecture number 1 for the strength of material, and I will come with a lecture series here. I will come with a lecture series here for this subject, strength of material, or this subject strength of material. Na? So definitely we will discuss all the things in the best way. Chapter number 1, 2, 3, 4, 5, everything from the gate exam, strictly to the gate examination point of view. If you're going for appearing next gate 2025 or gate 2026, definitely this video will help you a lot. Definitely. Okay. Okay, so if you find this video to very helpful for you and very good, definitely subscribe this YouTube channel, GATEFORUM YouTube channel, and like the video. And if you have any query, any doubt in the comment box, please put your questions. I will be replying you personally. I will be replying you. Okay, so that you can clear your doubts also. Okay, so thanks for watching the video. In the next video, in the same series, I will be coming with lecture number 2. I will be in lecture number 2. In the next, I will discuss elastic constant, elastic constants, elastic constants and thermal stress in lecture number 2. In lecture number 2, I will be coming with elastic constants and thermal stress in the second lecture. So today we have done in this video in lecture number 1 so many things regarding the stress and strain, simple stress and strain. And in the next video in lecture number 2, I will be covering elastic constants and thermal stress in very detail in the best way for your gate examination, coming gate examination. Okay, so thank you all of you for watching the video. Watch all the videos in this series, lecture number 1, 2, 3, 4, 5 and so on. Okay, and make your concepts of strength of metal best and like the video, subscribe the video. Bye all of you, bye.